Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
This video is going to focus on completing the square and utilizing it to help us solve problems. If you watch my factoring video, you would have noticed that factoring only works for certain types of quadratic equations where the answers are rational numbers. Completing the square is going to work 100% of the time when we solve it. Okay, so if you can do this, you can solve any quadratic formula. Quadratic equation, I should say, not formula. So first of all, what is completing the square mean? Let's think about this. A square has the same width as it does the length. Ignore my messed up drawing. So let's say we had x squared here, and we had 5 here, and we had 5 here. That would put a 5x here and a 5x here, and a 25 there. So a perfect x plus 5 square is equal to x squared plus 10x plus 25. Let's say we were given a problem in our last video. To solve this quadratic equation, we would have had to add the 19 over here so it equals 0 and then attempt to factor. This problem, though, should you graph it on Desmos or something like that, is going to have irrational answers, meaning answers that go on and on and on. So by completing the square, we'll be able to find the exact values without going through a lot of work. So the nice thing about this is we just looked at this, that if I had x squared plus 10x plus 25, I could rewrite it in this parenthesis form. So 25 would be the number that completes the square because it's the last box in the square. But if I add 25 to the left side of the equation, I also have to add 25 to the right side of the equation to keep it balanced. Once you do that, you can factor the left side into x plus 5 and x plus 5, or x plus 5 squared. And when I add negative 19 plus 25, I get 6. The beauty of this is now we can use what's called the square root property to solve. We can take the square root of both sides. Don't forget the plus or minus. So x plus 5 equals plus or minus square root of 6. So x will equal, I gotta subtract 5. Negative 5 plus or minus the square root of 6. So negative 5 plus root 6 and negative 5 minus root 6 will be our two answers. Looking here at Desmos, I have graphed the x squared plus 10x, and then I put plus 19, remember, because that's what it would be if you made it equal 0. And the reason why, we can touch those on. And if you look, negative 5 plus the square root of 6 matches the one on the right, and negative 5 minus square root of 6 matches the one on the left. So we have found the zeros or the roots to that particular quadratic equation. So how could I complete the square for any problem? That's going to go ahead and be the goal, to find the roots just by doing this process. So again, solving by completing the square will work 100% of the time. Okay. It's especially helpful when non-factorable. The other thing is it will help us find our complex roots should we need to find our complex roots. So I have a process that works very well for me, and I like to do steps. So first step, ensure that a equals 1. Second step, you're going to want it in the form x squared plus or minus a number x equals a number. I'm going to call that number b, and I'm going to call that number c. Our third step will be to add b divided by 2 squared to both sides. After you do that, the left side will factor to x plus b over 2 quantity squared. And then you will be able to solve using that square root property. So if we can follow those 5 steps, we can do this. One of the reasons why I teach this is also in the future for circles, especially if you're going to take college algebra. In the meantime, I do have a shortcut workaround for this if you get stuck. So keep that in mind. I will give you a shortcut workaround after I show you the proper way. So let's say we have x squared plus 16x plus 2. And this is what we're trying to solve. So the first thing we're going to do is ensure a equals 1, and our a value is 1. And then we want to get it in the format. Okay, so x squared plus 16x equals negative 2 because I subtracted 2 from both sides. Okay, I'm supposed to take my b value, divide it by 2, and then square it. So that would be 16 divided by 2 is 8, squared is 64. So I'm going to add 64 to both sides. So that gives x squared plus 16x plus 64 equals 62, because negative 2 plus 64 is 62. Now, if you agree, 8 times 8 is 64, and 8 plus 8 is 16. So I could factor it to x plus 8 times x plus 8, which, don't you know, hey, that's b divided by 2. And now we're going to solve using the square root property. So square root both sides. Don't forget the plus or minus. And subtract 8. Now I could write this as plus or minus root 62 minus 8. But I like to write it negative 8 plus or minus root 62. You should always check to make sure your radicals are okay and reduced. In this case, the square root of 62 is 2 times 31, and 31 is prime. So this is our final answer. You could type it in a calculator and get decimal approximations, but why do we need to? Okay, let's try another one. X squared minus 14x equals negative 60. So a equals 1, check. Okay, it's in the format. So step 2, check, it's already in the format. So we're ready to add b divided by 2 squared to both sides. Okay. Negative 14 divided by 2 is negative 7, and then negative 7 squared is positive 49. This now factors to x minus 7 times x minus 7. If you need to pause the video and double check and verify, then that's a great thing to do. But we purposely picked 49 because it made it a perfect square. Hence the word completing the square. Okay, we have a negative. Not a big deal. So now I'm going to go ahead and solve this using the square root property. X minus 7 equals plus or minus the square root of negative 11. Oh, that's complex, which means there are no real roots. The graph does not cross the x-axis. Okay. That doesn't mean I don't have roots, I just don't have real roots. So I'm going to add 7 to both sides. Again, I like to put it out front. Instead of writing negative 11, I'm going to write 11 with that I outside. So depending on how they word the directions, you're either going to say no real solution, or you're going to give that complex solution. All right. Now for some people, they like to think divide by 2 and square, which is really what we did. We divided by 2 and we squared it. So if that helps you keep things straight, it's okay. What happens if it's a fraction? It's a fraction. I will be demonstrating that as well. I mean, I'm not going to leave you hanging without doing a few fractions, right? 3x squared plus 9x minus 7 equals 0. Okay, well, a is not 1. So we're going to divide everything by 3. And I'm going to use fractions. I will not use decimals. So now we have x squared plus 3x minus 7/3. And 0 divided by 3 is still 0. Now I got to get it in the format. I'll move that 7/3 to the other side. Okay. b divided by 2 squared is our next step. So our b value divided by 2 squared. When I do that, I just 3 squared is 9, 2 squared is 4. So I'm going to add 9/4 to both sides. That gives me x plus 3 over 2 quantity squared. And if you grab a calculator and you do 7/3 plus 9/4, you will find out that it is 55/12. And again, divide by 2, square, right? Whatever you add to the left, you have to add to the right. So divide by 2, square. So I'm going to square root both sides. I guess I didn't need to write the parentheses. In case you do not remember, when you have radicals, which is square root is a type of radical, you can only have an integer underneath the radical in your final answer, and we have a ratio. So we need to turn this into an integer underneath. And the denominator has to be a nice perfect number. So right now we cannot do the square root of 12. However, 55 over 12 is equal to 165 over 36. And I would have gotten that just by doing times 3 times 3. So x plus 3 over 2 equals plus or minus 165 over 36. By doing that change, I can now get a perfect square root in the denominator. So make sure your denominator is always a perfect square so that we can reduce our radicals properly. So we get x plus 3 over 2 equals plus or minus, I don't know the square root of 165, but I do know the square root of 36. And now, while I still have a fraction, I have an integer underneath the radical. Now I can finish getting the x by itself. And this is an exact answer. It's not rounded. You are frequently going to be asked to find exact answers. Okay. Those all had an equal sign and only an x value. What if they give you y equals equation and they ask you to write it in vertex form? Well, vertex form is actually completing the square form. So we're just going to go ahead and complete the square. Just instead of a 0 or a constant, we have a y there. It's going to work much the same. So I'm going to divide everything by 2. I'm going to move this number by itself. It's in the same format, it's just flip-flopped. Okay, now I have to add that b value divided by 2 squared. So 6 divided by 2 is 3. And 3 squared is 9. So I'm going to add 9 to both sides. And I'll factor this because, remember, divide by 2, square. 3 times 3 is 9, 3 plus 3 is 6. And now I need to get y by itself again. So I'm going to multiply everything by 2. Because of order of operations, I can't actually distribute the 2 through the parentheses. And then I'm going to move my 13 back over. In one of my previous videos, you would have seen me show a way to go directly from this blue equation to this bottom pink equation by finding the vertex. The first step we did to find the vertex was negative b over 2a. In our case, that would be negative 12 over 2 times 2, which is negative 3. And if I substitute negative 3 in, 18 minus 36, which is negative 18, plus 5, which is negative 13. So my vertex is at negative 3, negative 13, and my a value is 2. So if you recall in my previous videos, I had x minus h squared plus k. So in our case, that would be 2. X minus negative 3, so plus 3, plus negative 13. Look at that. This is just the vertex form. Okay. So let's say I had done that with my last example. 3x squared plus 9x minus 7 equals 0. Okay. Negative 9 over 2 times 3. Negative 9 over 6. Negative 3 over 2. Then I have to substitute that. So this would be 9/4 times 3. So that'd be 27 over 4. This would be minus 27 over 2. And this would be minus 7. So I'm going to make everything with a common denominator. 27/4 minus 54 over 2 over 4 minus 28 over 4. So 27 minus 28 is negative 1 minus 54. That's negative 55 over 4. So now we have our vertex, our a value, x plus 3 over 2 squared minus our 55 over 4 equals 0, right? So I just use my vertex to rewrite this. So I'll add my 55 over 4. Divide by 3. And if you'll notice, that is the same thing we had here. X plus 3 over 2 equals 55 over 12. So you can use the vertex to complete the square and to rewrite it. It works great when we're doing quadratics. If we're doing circles, you need to actually know how to complete the square. So if you're a step-by-step person, make sure that you write those steps down. That way you can kind of ingrain them in your memory so you get some good practice at that. So again, this is best if a equals 1. Can you do it when a doesn't equal 1? Absolutely, but you're going to have a few more issues if you are not great at thinking of perfect squares and factoring.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.